Hello, this is the luckiest maths teacher in the world. Thank you so much for watching. Today we go through back-to-back stem and leaf plots. So you would have seen stem and leaf plots many times. A back-to-back stem and leaf plot is just where we have two stem and leaf plots like on the same diagram. And we use this to be able to compare data. So I'm going to give you the stem and leaf plot and show you how we can use it to compare data. So I'm just going to make up a stem and leaf plot about, let's say, boys and girls have run a race and we want to see who's faster. Okay, so let's look at this back-to-back stem and leaf plot. So you have the stem in the middle always and two leaves. Each leaf is representing different data sets. So we always start from the center, so lower scores, lower numbers are closer to the stem. And remember, stem and leaf plots need to be ordered. So let's say that this side here represents boys and the other side represents girls, their time in a race. So for any stem and leaf plot, you need to be given a key. So the key for this will be something like, 6'3" equals 63 seconds. Took this person 63 seconds to complete the race. Now you probably have some ideas, some common sense ideas of how we would compare this data, and you probably have a conclusion mapped already. Who's faster, boys or girls? But let's see what we can actually mathematically get from this stem and leaf plots. So, firstly, what we can do is we can look at the type of data we have, the type of distribution. So for boys, hopefully you can see that this data is basically symmetrical. So it's a symmetrical distribution for boys. So remember, a stem and leaf plot is basically a histogram on its side. So if you were to turn this stem and leaf plot to its side for boys, you'd see a symmetrical distribution. Same number of high scores and low scores. If you would do the same for girls, you would see that there are a larger number of low scores, and then the scores kind of taper off. So remember, if there's more lower scores, we say that it's positively skewed. Now I want to make sure we understand that even though we're talking about a race and a lower score is like better because it means less time, the scores here are still lower. So it's still positively skewed. So positively skewed doesn't mean that the scores were necessarily bad. It means that the scores were lower. And sometimes lower scores are a good thing, as they are with a race. Okay, so what we can do now is we can decide whether or not there are any outliers for the boys and the girls. Again, we now have a way to do this mathematically rather than just looking at the data and guessing. So we'll first look at the boys. So for the boys, there were 13 scores all up. So what that means is the median will be the 7th score. N plus 1 on 2 is 7. So if we go up to the 7th score, it's right here at 27. So that is the median. So these two scores here and these 4 scores here are in the lower half. So for boys, we can write that Q1 will be the median of the lower half. So it will be the average of the 3rd and 4th scores. So it will be here. So it will be halfway between 16 and 18, so Q1 is 17. So we'll do the same to find Q3. So Q3 will be the median of the upper half. It'll be the average of the 3rd and 4th scores in the upper half. So 1, 2, 3, and the 4th score is 34. So the Q3 is halfway between 30 and 34, which of course is 32. We'll do the same for girls. So there are a different number of scores here, but that doesn't mean we can't compare them. So there are actually 19 scores for girls. So the median will be the 10th score. So we start counting from either direction, it doesn't matter. And so we come to this score here, and it is the 10th score. So there are 9 scores below that, and there are 9 scores above it. So that is the median. So the median is 34. So that means for girls, Q2 median is 34. So I'll write that down actually. So Q2 is 34. Q1 is the median of the lower half. So there are 9 scores in the lower half. So the median will be the 5th score. So we go So the fifth score is here at 26. There are 4 scores below it, 4 scores above it in the lower half, and we'll do the same for the upper half. The median will be the fifth score, so there'll be 4 scores above it and 4 scores below it, and that's this one here, 41. Okay, so what we can do is calculate the interquartile range very easily. So the interquartile range for girls is 41 minus 26, and for boys it's 32 minus 17, which is 15. So the interquartile range is the same for both of these. Now we can determine whether or not there's an outlier. So for boys, a score will be an outlier if it's less than 17 minus 1.5 times the interquartile range. So that actually gives you a negative number. So there's no scores less than that. You can't have a negative time. A score will be an outlier if it's more than Q3 plus 1.5 times the interquartile range, which is 54.5. So there were no scores less than negative 5.5, no scores above 54.5. Therefore, there are no outliers for the boys section. So we kind of expected that because the data was symmetrical anyway, just because of the way the data looks. But we've confirmed it mathematically. So for the girls, a score will be an outlier if it's less than Q1 minus 1.5 times the interquartile range, which is 3.5. There are no scores that were less than 3.5. It will be an outlier if it's more than 41, which is Q3 plus 1.5 times the interquartile range. Now that only equals 63.5. So we do have a score that's more than that, and that's 71. So girls actually does have an outlier. 71 is an outlier. So because girls is positively skewed and it has an outlier, the mean doesn't give us the best indication of the center of the data. It'd be fine to use the mean for boys, but it doesn't really work for girls. So what we want to do is we want to compare the two medians. So that's easy. For boys, the median was 27. For girls, the median was 34. So we can see that girls has a higher median. So as we sort of learnt in the previous lesson, we don't want to just look at the mean or just look at the median because it doesn't tell the whole story. Now again, because the data for girls is skewed, we probably don't want to use the standard deviation or the range. It wouldn't give a good indication of the spread. But what we can do is use the interquartile range. So we've compared their medians, and if we compare the interquartile range, we see that boys and girls have exactly the same interquartile range. This suggests that the spread is very similar for boys and girls. So now that we've calculated all these statistics, we can compare these data sets. We can compare them from the back-to-back stem and leaf plots. So for girls, the median is higher than for the boys, but the spread is about the same in each of them, so in each data set. So what that means is we can use this as evidence that boys were actually faster, their scores are in general lower. We probably could have guessed that before we did any calculations, but we want to work with calculations. We want to have some evidence to back it up rather than just saying that it's obvious. So that's what we've done here. We conclude that boys were faster because they have a lower median time to complete the race and the spreads were very similar. That's enough evidence to back up your claim. All right, hope you've enjoyed this video. This has been the luckiest maths teacher in the world. Have a great day.